Okay, everybody, let's go ahead and find the inverse of this matrix C. It is a 3 by 3 matrix. So I went ahead and set it up as an augmented matrix with the identity matrix attached on the right-hand side. So we need to go through and do row operations until we turn the left-hand side into the identity, and whatever's left on the right-hand side will then be our inverse. I've also put this augmented matrix in my graphing calculator in matrix A. It ends up being a 3 by 6, so go ahead and take a second to do that if you need to. Then what we need to do is pivot first around this top left one. It's already a 1, which is great. So all we need to do is the row operations to turn the ones below it into zeros. So it looks like what we need to do is take -1 times row 1, add that to row 2, and that will be our new row 2. And the same thing for row 3. Because a -1 added to a +1 will cancel those out. Okay, so we're not going to change our row 1 at all. We're just using it. So I'm going to recopy it down. And then we want to do our operations to change those other 2 rows. So I'm going to quit out of the edit mode, do another second matrix math this time. We're doing 2 times row plus operations. First, we're doing a -1 in matrix A. We are doing this to row 1 in order to change row 2, and then we're storing it back into matrix A to keep a running total here. So I've changed my row 2. My row 2 is now 0, 1, 0, -1, 1, 0. Okay, and now we really want to do the same thing, only to change row 3. So let's do another second matrix math times row plus. This time we're doing -1 in matrix A. We're doing this to row 1 in order to change row 3 though this time, and then store again. And now we have our new row 3, 0, 0, 1, -1, 0, 1. Okay, so now we want to pivot around that next one, the one in the middle. So again, we get a break because this is already a 1. We just need to change the entries above and below it into zeros. And we also get a little bit of a break because the one below it is already a 0. So we only need to do one operation to change that upper 3 into a 0. So it looks like we're going to need to do -3 times row 2, add that to row 1 to get a new row 1. All right, so we're only changing row 1, so I'm going to go ahead and recopy down my row 2 and my row 3 for this iteration. And then I'm going to go to my calculator to do a second matrix math. Another times row plus is needed. This time we're multiplying by -3, matrix A. We're doing this time to row 2 in order to change row 1, and then store. Okay, so my new row 1 is 1, 0, 1, 0, 3, 4, -3, 0. Okay, now we want to pivot around this lower right-hand 1. So again, it's already a 1. That's great. That's what we're wanting, is that diagonal of 1s. And the only thing we need to change into a 0 is that very upper 3. So it looks like, again, we're going to do the same thing we just did. We're going to do a -3, this time multiplied by row 3, though, since that's where our 1 is. Add that to row 1 in order to change row 1. And this should do it. So 0, 1, 0, -1, 1, 0 as row 2 is finished. 0, 0, 1, -1, 0, 1 as row 3 is finished, and we just need to fix that top row. So second matrix math times row plus one last time, a -3, second matrix A again, this time to row 3 in order to change row 1 and store it one last time. And here we go. So we have 1, 0, 0 as expected, 7, -3, -3. So this over here on the right-hand side is our inverse of C, or our C inverse. Okay, there is another way to move this, to find the inverse if you have a 2 by 2. So this works for a 2 by 2 only, this next example does. It's by using what we call the determinant. The determinant of A is if you have a square matrix of this form, so they've got A, B, C, D there as your entries, you can find what's called the determinant by calculating A times D minus B times C. So basically you take your diagonals, you take this going down to the right diagonal, and then you subtract, oops, I'm writing in the wrong spot here. You take this downwards diagonal and then you subtract this upwards diagonal from it. And then it says if the determinant is not equal to 0, then an inverse exists, and we can find it using this formula. This formula is something important that you're going to want to memorize, because on the exam, you will be directed to find an inverse specifically using the determinant. So you'll have to do it this way in order to get credit for it. Okay, so let's go ahead and practice on a couple of these matrices. So it says to use the determinant method, so that means we specifically have to first find the determinant. So the determinant of this A matrix is 2 times 5 minus this upper diagonal 3 times 3. So 10 minus 9 equals 1. So the determinant of A is 1. Since that determinant is not 0, I know that A has an inverse. And now here is how I find it. To find A inverse, we take 1 over the determinant, so in this case 1 over 1, and we multiply that by, now look at this weird matrix. So we multiply that by, notice the A and the D have just reversed. A to D is now D to A. So in this case I'm going to reverse my 2 and my 5. I'm just going to put those in different spots. And then the other diagonal actually stays in the same place, but it turns into their opposites. So these 3's don't move, they just both turn into their opposites. Now 1 over 1 is just 1, so there's not really anything to do here. This is just the answer. 5, -3, -3, and 2. This is A inverse. As a check, we could check and see, does A times A inverse give us back the identity? If we want to do that. So A is 2, 3, 3, 5. And the inverse that we're claiming is 5, -3, -3, 2. And if we wanted to, we could multiply this to see, does this really give us, and two 2 by 2's multiplied together will be a 2 by 2. So let's see, it would be taking 2 times 5, which is 10, plus 3 times -3, which is -9. Well, 10 minus 9 is 1. And it would be doing 3 times 5, which is 15, plus 5 times -3, which is -15, so that would be a 0. And then 2 times -3 is -6, plus 3 times 2 is 6, so I get my 0 here. And then 3 times -3 is -9, plus 5 times 2, which is 10, so there's my 1. So it does check. Okay, as far as, let's try to find the inverse of matrix B here. So our determinant is 4 times 3 minus 6 times 2, but that is 12 minus 12, which is 0. So if you get a 0 determinant, you can just stop right there and say that the inverse does not exist. B is what we call singular. So that's a quick way to realize also that there's no need to move on. Instead of going through and doing a bunch of row operations to eventually find out that you can't find an inverse, this is a really fast way to realize that you can just stop.